Welcome to Module 4, Lesson 13, Changing Scales. Okay, so you are going to be given a drawing 1 and drawing 2 in this lesson, and you will take a look at how they relate to one another. So in the past, we've always had that one model or that one drawing serving as our original, and then moving up from there as an enlargement to a scale drawing, and then down to a reduction, another scale drawing. This time we'll swap it around. We'll look both ways. So we're not necessarily going to have one original drawing, but we will be working from different drawings. So anyway, I know that probably makes no sense, but it will in a minute. Okay, here we go. Okay, so here is our opening exercise and a little reminder here about scale factor and how we get scale factor. Of course, that is the length in the scale drawing and the corresponding length in the original drawing. And again, always remembering that original sits in the denominator, okay, because it is the one we are comparing to, okay. But again, like I said, in this lesson, we're going to be that original, quote unquote original, is going to be changing, okay. All right, so yeah, there we go. I did that again, and so what we're going to do here is we're going to describe using percentages the difference between a reduction and an enlargement. Okay, that's the first thing we want to do. Seems pretty simple to me. Okay, so now, but they want you here to describe using percentages. Okay, so a reduction, scale factor less than 100%. Enlargement, scale factor greater than 100%. Okay. Alrighty, so yeah. Oh, I'm sorry. I'm gonna go back. I don't want to do that yet. But yeah, that's pretty much a big duh. I think I'm going to use the word duh a couple of times in this lesson. I know some things just seem so obvious to me. Maybe they don't. Maybe they don't to others. So I apologize if I say duh at an inappropriate time. And of course, I'm not saying it to anybody out there, but just to these things here on these pages. But anyway. Here we go. Our first task here, therefore, is to use the two drawings below, okay, drawing 1, drawing 2, to complete the chart. Okay, so calculate the first row, drawing 1 to drawing 2 only. Okay, the first row, drawing 1 to drawing 2, so that's this one, this row right here. Okay, so finish this, complete this row. If you want to, I'd like you to pause and go ahead and do that yourself. Okay, so go ahead and try to go ahead and do that yourself. So I'm going to pause right here, then I'll come back, we'll do it together. Of course, if you don't want to do it yourself, just come back and see what I do. Okay, let's go ahead and do this together. Drawing 1 to drawing 2. Okay, so we're going from drawing 1 to drawing 2, therefore we can see right away that it is an enlargement. Okay, we'll just go ahead and cut to that chase. We can tell that it is an enlargement, okay, which is good. I mean, as soon as we know that, we know a few other things. It's kind of a built-in way to check our answers, to make sure we are accurate with our answers, okay. So let's go ahead and do some figuring. Okay, we're going to create some fractions here, ratios. Okay, so we have 3.92. Okay, and that comes from right here, 3.92. Again, that is the new, or the scaled up, in this case, scaled up drawing. Okay, so it goes on the top. It is our numerator. And of course, 2.45 comes from here because we are that is the original. Okay, we're going from there to another one, to another drawing. And that's probably the most complicated thing, and the most difficult thing to remember is where to put the number. But the key is this. You know it is an enlargement, okay? You can tell you're going from a smaller drawing to a larger drawing. It's an enlargement. Therefore, this numerator has got to be greater than the denominator, okay? Because you need something that's going to come out to be more than one whole or more than 100%, okay? All right, and in this case, it comes up to 1.6. 3.92 divided by 2.45, 1.6, and that's our horizontal distance. Let's go ahead and get the vertical distance. Now we're moving up and down, and we have 2.4, okay, which comes from here, the vertical distance of drawing 2 over 1.5, which is the vertical distance of drawing 1, and as you can see, that is also 1.6, okay? So we're looking at a single scale factor as a percent, and of course that is going to be 160% because that's what 1.6 translates into, okay, or is equivalent to. All right, and of course it is an enlargement. All right, so we're going to go ahead and we are going to go to the next page here because there are a couple of questions to answer. Didn't want to do that. Okay, I didn't want to do that either. Oh, boy. Okay, here's what I want to do. And don't want to do that. I want to get rid of all this. See the word duh there? Okay, here we go. I know this is a little bit confusing because I went back and forth when I did my original strokes. All right, here we go. So we're going to compare drawing 2 to drawing 1. Okay, so using the completed work in the first row, okay, make a conjecture, a statement about what the second row of the chart will be, okay? So, we're going to, we're not going to compare drawing 2 to drawing 1 yet, okay? We're going to do it, okay? But we want to use the completed work in the first row firstly to make a conjecture, okay, and I wanted to talk about that word conjecture, okay, and conjecture is an opinion or conclusion formed on the basis of incomplete information, okay, so we don't have all of the information. What we do have is we have the information that we have collected from our row 1. Okay, and so based on that, we are going to go ahead and make a conjecture about what we're going to see in the second row. Okay, and here's what I wrote. Drawing 1 will be a reduction of drawing 2. Duh. Okay, I mean, that seems to be one of the things that they wanted us to conjecture about. Okay, and that seems pretty darn obvious to me, okay, that is going to be the case, all right? Therefore, the scale factor from drawing 2 to drawing 1 will be less than 100%, okay, which again is a big duh, okay? So there we go. So I have my second conjecture there, okay? So I make sure we did. Now, furthermore, I wanted to emphasize I wanted to predict a scale factor near 60%. Okay, now the fact that I have conjectured a scale factor of less than 100% makes sense because it is indeed a reduction. Okay, that makes sense. Let's see how close I come. Okay, I just want to go back here and let me do this. Get rid of all that. Okay, I know you saw that already probably. Anyway, let's go ahead and do it then. So drawing 2, now we're going from drawing 2 to drawing 1. Okay, and you see where those numbers come from. What happens now is we've just flip-flopped. Okay, pretty easy to see. So instead of 3.92 over 2.45, we've flip-flop these, and we've gotten 2.45 over 3.92, which gives us a decimal value of 0.625, and the same for the corresponding vertical distances, okay? Scale factor, 0.625 is equivalent to 62.5%, which was really, really close to what I had guessed or predicted or conjectured, okay? And I was just kind of taking a look at it and just seeing how much exactly would that have been reduced, because it looks like it's been reduced to more than half its size. To less than half its size. Okay, so I just added a little bit there, 62.5%, and of course it is a reduction. Another duh. Sorry. Okay, and here's all this again. Let's just get through this. I'm sorry, I should be pausing here probably. Let me do pause and get through all this. I'll be right back. Okay, yeah, so here the question was, we completed the second row of the chart. Was your conjecture proven true? Yes. Explain how you know. Well, I won't go into it much further, but I know, of course, because my scale factor turned out to be 62.5%, which is less than 100%, which means it was a reduction. Okay, duh. That's it. Sorry. I think that's the last duh I have on here. Anyway, yeah, bear with me. I get just a little bit impatient with these things. I guess I'm just assuming that you guys are kind of getting it, motoring through it, and I do apologize for those of you for whom I might be going a little bit too hastily through this. Okay, so forgive me. All right, here we go. Well, next one here, we have a couple of hearts for Valentine's Day, which is over, of course. Okay, the scale factor from drawing 1 to drawing 2 is 60%. Okay, so they're telling us that already. Okay, we are now going to find the scale factor from drawing 2 to drawing 1. Okay, well, what do you notice about these? First of all, never assume in this binder that anything is actually drawn to scale, okay, because that may indeed not be the case. Therefore, they've given us no measurements. They've given us no measurements, okay? All we have are these hearts, which are really difficult to deal with in terms of measurements because there's no squared edges or even perfectly round figures to work with, okay? But there is another way, and I would like you to pause, ponder that for a second or two, and then come on back. How could we find that scale factor from drawing 2 to drawing 1 when we know from 1 to 2 is 60%, okay? Just think about it for a bit. If you have no idea, just come directly back. Okay, well, I had another one of those moments where I got through this entire page here and looked up and saw that my little clock was not moving. Therefore, I have a feeling that I went through this entire page here without saying a word to you. So bear with me if I've said some of this before, but I'm going to do it all over again. Okay, so here we go. We are going now from 2 to 1, okay? And I'm going to show you something. It's a bit of a shortcut, because what you notice here is we have no measurements, okay? We have no actual unit measurements that are measuring the width or the height of these hearts, which, I mean, admittedly, and as you can see, very obviously, are not very easy to supply measurements for, okay, as they are very unusual shapes, all right? But what do I know at this point, okay? What do I know going from 2 to 1? Well, the first thing I know is that it is an enlargement, okay, because I am going from a small heart to a large heart, therefore it's going to be an enlargement, and I know that my final answer, my scale factor, has got to be more than 100%. Okay, so these are some things that I know. All right. Now, when I'm figuring this new scale factor, okay, going from 2 to 1, I'm going to be using the value that I have from 2. I'm going to use that as my denominator, okay? Now, where am I going to get this from, you may ask, okay? And, well, I'm about to show you, okay? But we're going to use what we already figured from drawing 1 to drawing 2, okay? So we figured already, we've already calculated that going from drawing 1 to drawing 2 is a scale factor of 60%. Of course, that's a reduction, all right? So we have our value for 2, okay? We have our value for 2. Our value for 2 is 60%, okay? Now, what that would mean when we did our first drawing, okay, for our first scale factoring, or we didn't do it, they did it, that number 1 is going to be represented as 100% because that is that was the original when they created that first or calculated that first scale factor, okay? So therefore, we're going to use these values, this 100% for 1 and the 60% for 2, we're going to use those and we're just going to plug them in the correct place. Okay? Well, as you can see right there, we are going from 2 to 1. Therefore, we have our 60% is our denominator, okay, because we are actually doing a new scale factor, all right? And again, the original value always comes on the bottom, all right, always goes to the bottom. And then we have our 100% on top because that is where we are going to, okay? All right, and again, I saw this. Yeah, actually, these are the strokes. These are new strokes that I just put in. Okay, so yeah, I'm just locating with arrows now where those values go. Okay, and what I did here now, so 100 over 60 reduces down to 5 over 3. Okay, just getting down to a trying to get down to a lowest terms here, and then that gives me 166 2/3%, okay? 5 divided by 3 gives me that percentage. Of course, on a calculator, you know that looked like 1.6666, all right? That repeating 6, therefore I use the fraction in my, in my percentage, okay? And as you can see, right, it's an enlargement, so we know, okay, that 166 2/3 is reasonable at the very least because it is more than 100%. All right, so this is a very handy tool, okay, to be able to use when you want to actually find out a scale factor from the smallest to the largest when you've already done from the largest to the smallest, and we needed no measurements whatsoever. All we needed were the original scale factors. Okay, so nice little shortcut, a handy tool. I don't think we do any more of these in this lesson, but hopefully it does come up. I'm sure they'll throw it into the assessment or into your problem set. So be ready for it. Okay, lots of more strokes there. There we go. Okay, so here we are next. Excuse me. This one's going to take a little while to do, this problem and this example, simply because we are doing lots of different scale factors. Okay, we are going from drawing 1 to drawing 2, drawing 1 to drawing 3, drawing 2 to drawing 1, drawing 2. You can see it, okay, all the way down here. 1, 2, 3, 4, 5, 6 scale factors we are coming up with. So, what I would like to do, therefore, is to pause here. I would like you to pause. I'd like you to take your time and come up with the scale factor. If you want to just do the scale factor first, this column right here, figure out all of our scale factors, and you have the numbers that you need. You have the dimensions here that you need, because this is these are examples of regular octagons. Actually, let me go through this a little bit here. Okay, I'm just going to do this first part, which is really important. So, a regular octagon is an 8-sided polygon with side lengths that are all equal, okay? All right, and it's a very handy little definition to know, a good definition to know, okay, is this idea of a regular octagon. You can have a regular hexagon. You can have a regular triangle. All of those, whenever you see regular in front of those shape names, you know that all the sides are equal. Very, very handy, okay? So we're going to go ahead and use the chart and the side lengths to compute each scale factor as a percent, okay? And so what I would like you to do, we'll answer that question, how can we check our answers later, but I would like you to go ahead and 1, 2, 3, 4, 5, 6 different scale factors to calculate, okay? So go ahead, take your time, do well, come on back and check your answers. Okay, we are back. All right, we're back. Let's start. There we go, and just put a line to there. Yeah, all 3 octagons are scale drawings of each other. Okay, so they're all scale drawings of each other. Okay, we're just going to assume that. We're going to assume these lengths are all correct. Again, don't trust anything being honestly, actually drawn to scale. Okay, and yeah, we're going to use these. Use the chart down here and fill this chart in. Okay, so firstly, we're going from 1 to 2. Okay, that's our first row there. It says drawing 1 to drawing 2. Let's go ahead and do it. 12 over 10. Okay, why is that? Well, the 10 is going to serve as our original. Okay, because that's where we're starting from. And then 12, and it makes sense. The 12 over 10 is going to be more than 1, which means it's going to be more than 100%, because it's very obvious that it is an enlargement. Okay. And that equals 120%. I'm going to cut to the chase. I'm not going to put 1.2, etc., etc. We know now, if you are to this lesson, this is lesson 13, you are probably doing super, super well, and you are really understanding this. We can go very easily from 12 over 10 to 120%. Of course, 10 is so easy to work with on the bottom. Okay? All right. Now we're writing an equation now to illustrate this relationship. You see where the 10 came from. Okay, the 10 came from that original drawing, okay, on the bottom. And then we're going to multiply that by the factor, the scale factor. In this case, we're going to put 1.2 when we write our illustration, when we write our equation, okay, and that equals 12. And you can see how that works. All of those numbers, or every figure from that scale factor calculation, ends up in our equation, okay, to illustrate this relationship. Okay? All right, let's go ahead. This might not take too long. I'm hoping you guys are motoring along. You might want to even skip some of this if you want. But, okay, now we're going from 1 to 3. And again, since we are creating a reduction, we can see that our fraction makes absolute perfect sense. 8 over 10. Okay, 8 over 10 makes sense because it is going to give us a scale factor of 80%, which is less than 100%. Okay. Here we're going to go ahead and put our numbers in again. Our original value, 10, times our scale factor, in this case as a decimal, is 0.8, and that's going to give us 8, which is the scale drawing in this case. Okay? All right, we're moving along here. Now we're going from 2 to 1. Okay, and if you right now are a little bit confused and you hadn't done this correctly and you noticed that, why don't you go ahead and pause and start working on it. Start working on them again with your newfound knowledge. Okay, otherwise just keep watching. All right. So we're going from 2 to 1. Here we go. Now our fraction is 10 over 12, which makes absolute sense because we are creating a reduction. And 10 over 12, of course, is less than 100%, and it's actually 83 1/3% when we do the division. Again, plugging in the right numbers into the equation, that 12 is the original, where we start. The 83, or 0.83, is the scale factor as a decimal. And then, of course, 10 is... Well, I am very, very sorry. What seemed to have happened was, I'm so sorry, this has just been a total mess up here, but my iPad has decided to alert me that my battery was low, and what I had yet to learn was that when it alerts you that your battery is low, it turns off the recording. Okay, so what it did is it turned off the recording there while I was blah, 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 and therefore you heard me say very little, okay? Anyway, I am not going to go back and do this all over again because I think I did get partly through it. Here are all the answers, okay? If you would like, just go ahead and study what I have on my chart here on my table, okay? And you can just go ahead and see where maybe you might have gone wrong. I color-coded them, all the arrows that go along with the different calculations, and hopefully that makes it easier for you to work with. Again, if it's too confusing and you really need you need further explanation, please let me know, and I will help you out. I'm thinking it might even be a relief because all I did was go over the same process again and again and again. Okay, but it's pretty obvious what the process was. So again, if you really feel you need some further explanation on what happened here, just give me a call or send me an email. Okay, again, apologies. Well, at least this will make for a shorter lesson, okay? All right, here we go. We're on to our next one. We have our example 3. All right, in example 3, it says, now again, they're giving us a scale factor, telling us it's kind of like the hearts before. The scale factor from drawing 1 to drawing 2 is 112%, and you can see it written right here, okay? From drawing 1 to drawing 2, 112%. And the scale factor from drawing 1 to drawing 3 is 84%. Okay, and you can see that right there. Hard to see that 84%. Well, at least hard for me to see it. Anyway, okay, so they're telling us these things. Okay, again, we have no measurements. This is very similar to the heart problem in that sense. Okay, again, 112%, and drawing 2 is also a scale drawing of drawing 3. Okay, so they're letting us know that, and that's this kind of this unknown, this arrow right here. That's what that is referring to, just letting us know that it is a scale drawing of drawing 3. Okay, now the question, here's the question they are asking us here. And again, without measurements, we are going to answer this question. Is drawing 2 a reduction or an enlargement of drawing 3? Okay, and this is 2 right here. You can see it, 2 and 3. Now this again would seem like a big duh, okay, because it surely looks like a reduction, okay? But they are giving us this little tidbit here. The drawing is not necessarily drawn to scale, okay? So they are not necessarily drawn to scale, but using this number and this number, we need to justify our answer of enlargement or reduction, okay? All right, or reduction or enlargement, okay? So let's go ahead and do that. So we want to apply some of these percentages now to the different cars here, okay? These different little race car drivers, as it looks like. And so we're going to use 100% to stand for 1, okay? Because, well, I'd love to ask you why, but again, like very often, you're not here to ask. Because we have, the scale factor, we're going from drawing 1 in this case, and from drawing 1 in this case as well. Okay, so it is our original in both of those cases. Okay, and those two things we know. Okay, so drawing 1 is going to stand as our 100%. Okay. Now, of course, drawing 2 is 112% because that's how it compares to drawing 1. And, of course, drawing 3 is going to be 84%. Okay, so now we have those three. And again, just like the heart problem, we are applying only the percentages, the scale factor percentages to instead of actual measurements. Okay, so if we do that, we have 112. Okay, over 84. Okay, so where do those come from? Okay, where they come from are right here. Okay, we have 84% here, and now we are trying to test. We're trying to go from 3 to 2. Therefore, always that original. So in this case, this is going to be our original, which sits, of course, in the denominator. All right, and this is going to be our numerator because that's where we're going to. We're trying to test whether this is a reduction or an enlargement. And as we can see already, well, we're actually going to get a number here, an actual percentage. But as we can see, it is, of course, an enlargement. Because if we do figure this out, 4 over 3 is 133 1/3%, okay, when we go from 3 to 2, all right? And of course, it is an enlargement, all right, which we knew already by looking at it, but of course we can't assume anything because very often things in these binders and other worksheets and such are hardly ever to scale, truly to scale. Okay, well, hold on. I think I missed a question down here. Okay, so I think I saw this before, but explain how you could use the scale factors from drawing 1 to drawing 2 and from drawing 2 to drawing 3 to show that the scale factor from drawing 1 to drawing 3 is 84%. Okay, well, that's just a little extra. Well, why don't you do that? Try that one. Go ahead and work it out like we worked this out over here. Explain how you could, explain how you could use the scale factors from drawing 1 to drawing 2, which is 112. Okay, that was this one here. Okay, and from drawing 2 to drawing 3. Right now they're giving us another one. This is a new one. For they're saying from here to here is actually 75%. Okay, so they want us to use this and this to prove that going from 1 to 3 is 84. So we're trying to actually prove this one. Trying to prove this using this one and this one. So go ahead and ponder that. Boy, it's only 33 minutes and we're actually to our summary page. Go ahead and work that out. This is a really great little problem. I had missed it my first time around when I put these strokes together. But go ahead and work that out and come on back. Okay, let's give this a whirl. Okay, let's get rid of all this. First, get that big mess out of our way here. Okay, so we are trying to explain how we could use that scale factor, okay, going from 1 to 2, which is 112%, okay, over to, and using that scale factor from 2 to 3 of 75%. This is actually a new one that was given to us down here. Okay, given to us down there. All right, how we could use those two to figure out or to to justify that going from 1 to 3 is actually 84%. Okay. Well, not so easy. I'm not sure what you guys came up with, how you did it. There are some ways to finagle numbers, but we're not looking at division this time, okay? Because what we look at right here is that if we know going from 1 to 2 is a 112% enlargement, okay, we're going to use that 112%. So now this becomes 112%, okay? Now this is a reduction here of 75%, okay, right there. And again, this may not make any sense at the end, but maybe it will, right? Now, this, number one, stands as 100%, okay? It becomes, right now, our original, because we're working around, as you can see, in a little circle here, okay? But this right here, where does that 84% come from, or how can we use these two, okay? Well, in essence, or in truth, and again, I'm not sure how much sense this will make to you, but going from number 3, okay, is going to be 75% of 112%, okay? 112%, which is 1.12, 112%, or 75% of course, means that we multiply, okay? So I am doing 75% of 112%, okay? So this is actually what I am doing, and I'll show you how it works in different ways too, okay? How it would work as 112% or 100% otherwise, okay? So if I do that, if I know that I need to come up with 75% of a 112%, and if I do that multiplication and you multiply through, that comes out to a 84% or 0.84, okay, which is 84%, okay. That's where that comes from. So again, I'm not sure why they threw that in there. It's a little bit difficult to get your mind around, I understand, but yeah, that is how we could actually finagle or use those numbers to get from to use those two figures of 112% and 75%, get to that 84%. Okay. All right. Anyway, it would make sense. And again, you can look at it again. I don't want to belabor this point, but we are only 37 minutes in, so I feel like I have all the time in the world here. But it also makes sense because, first of all, we know that 2 is larger, okay, than 1, okay, which would make sense that the reduction, okay, is a little bit. See, a 75% reduction is going to come here be the same as an 84% reduction over here. Okay. Now, I'm not sure. That seemed to make sense, but now all of a sudden it doesn't. Anyway, don't worry about it. This is not that big of a deal. But well, hopefully you enjoyed this lesson, and let's go ahead and summarize before I get myself too deep into a place where I don't want to go. Anyway, here we go. Lesson summary. To compute the scale factor from one drawing to another, use the representation quantity equals percent times whole. Okay, they continually come back to that, which makes sense, and that's exactly what we were doing when we were creating these equations in this lesson past. It might not have been that blatantly obvious, but it is indeed what we were using. Okay, where the whole is the length in the actual or original drawing, okay, and of course that goes as our denominator, okay, and that's why it is down there, because it represents that original or actual drawing. And the quantity, of course, is the length in the scale drawing, okay, and that's the actual scaled number, or the one we come up with at the end. If the lengths of the sides are not provided, but two scale factors are provided, okay, and that's the case with the hearts and also with those cars, use the same relationship, but use the scale factors as the whole and the quantity instead of the given measurement. Okay, so again, a very handy tool. If you don't have exact measurements, you can just use those scale factors to come up with the scale drawings, okay, or the percentages of reduction or enlargement. Okay, well, anyway, I'm sorry, it's a little bit of a haphazard lesson here. Hopefully I didn't confuse you too much, but if I did, please know that I am always at the end of an email or a telephone call. Okay? Thanks.